I just finished reading a truly remarkable physics paper titled Control of the Natural Forces by my friend and fellow scientist Frank Znardzic. Frank has been researching cold fusion for the past 25 years. He has degrees in electrical engineering, University of Pittsburgh, and business administration from St. Francis College, and studied physics at the University of Indiana. This revolutionary new theory shows a way to calculate spectral emissions of photons using a purely classical approach. He also believes to have discovered the path of the quantum transition that electrons take when they change orbitals, and in the process has discovered a potential way to control each of the natural forces through this transition. Let's start with some interesting experiments that have been virtually ignored by most of mainstream science. In 1995, Frank Znardzic and Judd Rothwell went to Anaheim, California to view the cold fusion cell developed by Clean Energy Technologies Incorporated. James Patterson used an infrared preheater to bring on the cold fusion effect by stimulating 50 nanometer sized palladium crystals. He was the first to discover that infrared stimulation enables the reaction to proceed. Dennis Cravens and many others extended this idea and used laser stimulation to get the process to work more efficiently. This was Frank's first hint that thermal vibrations had something to do with the process. Edward Storm, a retired Los Alamos scientist, also found that the cold fusion erupts from microscopic regions. Russ George of Planktos came to a similar conclusion. Professor Yoshiaki Arata of Osaka University reported a cold fusion reaction using fine-grained 50 nanometer palladium black, a type of nanopowder. Most recently, the U.S. Navy Cold Fusion SPOIR Research Center discovered the same phenomenon. The SPOIR Center took it a step further and actually detected the tracks of ejected high-energy particles. Professor George Miley of the University of Illinois has detected the transmutation of elements in his cold fusion experiments. It was beginning to look as if cold fusion may turn out to be a real phenomenon. In 1999, Judd Rothwell was one of the first to suggest that 50 nanometers was the domain in which the cold fusion reactions could occur. Znardzic multiplied the thermal frequency, which was approximately 10 to the 14th hertz, times the 50 nanometer dimension and got a velocity of 1 million meters per second, which is nearly the speed of light. Could this just be a coincidence, he wondered? In 1992, Dr. Eugene Podkletnov stimulated a 34 centimeter yttrium-barium copper oxide superconducting disk at 3 megahertz. The experiment produced a gravitational anomaly that attracted worldwide attention. Martin Tajmar performed similar experiments for the European Space Agency and got similar results. NASA's Marshall Space Center followed with some experiments of their own. Frank Znardzic was invited to NASA by Whit Brantley and David Nover to watch these experiments firsthand. To his surprise, the same velocity emerged. 1/3 of a meter times 3 megahertz equals 1 million meters per second. Znardzic concluded that this must be the velocity of light inside of the medium. The velocity of light is normally c, however it goes slower, 0.9 c, in mediums like glass. Inside of a superconductor or Bose-Einstein condensate, it can go even slower. Recent experiments with Bose-Einstein condensates have gotten light to stop and turn around. Znardzic believed that this velocity was also that of the quantum transition. Normally, quantum transition is described by the stationary quantum state. These stationary quantum states have an amount of angular momentum described by n times Planck's constant. This understanding of these stationary quantum states is the basis of our fundamental understanding of the universe. It underlies chemistry, which in turn underlies biology. Frank Znardzic believed that the velocity exhibited in these new experiments was also that of the transitional quantum state and wrote his paper to prove it. This is the transitional quantum state now revealed. Coulomb described the electrical force with his constants q, etc., and variable radius r. Znardzic rearranged the constants in the form of the elastic energy of a spring. Together they equal a group constant k. The variable 1/r remains the same. Amazingly, the new form revealed the classical radius of the electron, 2rp. However, that's not nearly as important as what else he discovered. The mechanical elastic constant and displacement 2rp can be used to determine the velocity of sound within the electron. You see, the strength of the electric field varies with distance r away from the electron, and this is reflected in this variable elastic constant. The speed of sound also varies at different locations within the electron. The velocity, 1 million meters per second, was then written in terms of a product of frequency and wavelength. Znardzic assumed that this was the velocity of light within these experiments. The condition of the velocity of light was set equal to the condition produced by the velocity of sound. The velocity of a wave in a medium is determined by the stiffness of that medium. The greater the strength of the forces within that medium, the faster the wave propagates. This is why sound travels faster in steel than it does in water. In the case where all the waves are going at the same velocity, the strength of the forces between the components is the same. This implies that the strength of the electromagnetic, gravitomagnetic, and nuclear forces converge under this condition. This discovery has important technical ramifications. It shows the conditions necessary to control the natural forces, as in controlling gravity and nuclear forces. This idea does not end in the clouds, however. It can also be used to produce the structure of the hydrogen atom in equation 12. This has never been done from a classical premise. Not only that, but the structure was extended to produce the intensity of spectral emissions. Finally, if you set Rx equal to the radius of the hydrogen atom, the elastic energy contained by an elastic discontinuity of displacement 2rp equals the zero-point kinetic energy of the ground state electron. Frank suggests that the natural force fields are pinned into the structure of matter at this discontinuity. The transitional quantum state removes the discontinuity and releases the fields. Maxwell's theory predicts that accelerating electrons will continuously emit electromagnetic radiation. Bound electrons experience a constant centripetal acceleration, however, they do not continuously emit energy. An atom's electrons emit energy at discrete quantum levels. The quantum nature of these emissions cannot be accounted for by any existing classical theory. Quantum theory assumes that the gravitational force is always weak and ignores it. This is a fundamental mistake. During transition, electromagnetic and gravitomagnetic flux quickly flow from the parent to the daughter state. This rapid flow progresses by way of a strong electromagnetic and strong gravitomagnetic interaction. The velocity of the centric transitional electronic state, Vt, was expressed as the product of its frequency, Ft, and wavelength. Lengths of energetic accessibility exist at Rp. The velocity of the atomic transitional states are integer multiples of this fundamental length. A solution yields the frequency of the transitional quantum state Ft for the isolated electron. This frequency Ft also equals the Compton frequency Fc of the electron. The transitional quantum state is a Bose ensemble of stationary quantum states. The interaction of the fields within this ensemble resembles that of electromagnetics within a superconductor. The infinite permeability of the ensemble confines the static fields. The zero permittivity of the ensemble expels the dynamic fields. These effects extend to the ends of the condensation. The motion constants vary directly with the extent of the condensate. The frequency of the ensemble is a function of its motion constants. For a Bose condensate n greater than 1, the frequency Ft varies inversely with the radius of the condensate. These effects describe the diforce field of the transitional quantum state. The electron vibrates in simple harmonic motion, with its frequency Fn being a function of its elastic constant and mass. The frequency of the transitional state Ft was set equal to the natural frequency of the electron, Fn. The resultant equation provided a simultaneous solution for Rx. Solving for Rx results in equation 11. The quantity within the brackets equals the ground state radius of the hydrogen atom. The reduction of the terms within the brackets produces equation 12. The result, Rx, equals the radii of the hydrogen atom. A condition of energetic accessibility exists at points where the natural frequency of the electron equals the frequency of the transitional quantum state. The energy levels of the atoms exist at points of both electromagnetic and gravitomagnetic accessibility. The intensity of spectral lines was qualified by Heisenberg. He described the position of an electron with a sum of component waves. He then placed these component waves into the formula of harmonic motion. Bohr's quantum condition was then factored in as a special ingredient. Heisenberg found that the intensity of these spectral lines is a function of the square of the amplitude of the stationary quantum state, and that has been the basis of 20th century quantum mechanics ever since. The great scientists knew nothing of the path of quantum transition, so their solutions did not incorporate the probability of quantum transition. Frank Znarczyk claims to have discovered the path of this quantum transition. The amplitude, or displacement, of vibration at the dimensional frequency of 1.094 MHz meters squared is proportionate to the probability of transition. The transitional electron may be described in terms of its circumferential velocity. Equation 13 describes the spin of the transitional quantum state. Angular frequency times the radius of energetic accessibility equals the velocity of the transitional quantum state. The transitional frequency of the daughter state is a harmonic multiple of the transitional frequency of the parent state. Equation 16 expresses the transitional amplitude in terms of the product of the amplitudes of both the parent and daughter states. The factors within the brackets equal Planck's constant. The reduction of the terms within the brackets produces equation 19, which gives us Heisenberg's formulation for the amplitude of electric harmonic motion squared. Interesting. This formulation expresses the numerical intensity of the emitted photons. The intensity of a spectral line is a function of the probability of transition. The probability of transition is proportionate to the product of the transitional amplitudes of the parent and daughter states. These constructs reform the very foundations of modern physics. This reformation is classical. It may be possible to influence these classical parameters and construct devices that directly employ all four of the natural forces. This control will lead to the development of many new technologies. The amplitude of a single nuclear state is small, however the amplitude of a lattice vibration is large. The product of these two amplitudes is great enough to allow for a cold fusion reaction to proceed, or to overcome the Earth's gravitational field.